Hello everyone. So in this lecture we will be discussing about an algorithm which seems like that we can optimize it with the help of DP, but actually we cannot. So we are discussing this algorithm over here because we need to make a distinction between such algorithms and the algorithms which really can be optimized with the help of DP. So what algorithm we will be discussing over here? We will be discussing about the merge sort algorithm. So and how does merge sort actually sorts the array? It just sorts the array by dividing each and every subproblem into two halves. And how does it divide the array or the subproblem in two halves? By taking the mid element. So how does it calculate the mid element? By just adding up the lower index and the higher index and dividing it by 2. So what would be the mid element of this array? So these are the 10 integers we are working on. So the mid element of this array would be 4 because 0 plus 9 divided by 2 would be 4. So what we will be branching out for? We will be branching out for merge sort 0, 4 and merge sort 5, 9. So what does these subproblem say? These subproblem says that if we sort the elements 0, 4 and if we sort the elements 5, 9 and then we merge both of these sorted arrays, then we will get an answer to merge sort 0, 9. So the same way we will be branching out for 0, 4 as well. What we will be branching out? We will be branching out for 0, 2 and 3, 4. Then again we will be branching out for 0, 2 with the help of merge sort 0, 1 and merge sort 2. But we will see that 2 is a base case. And why is it a base case? Because a single element is always sorted. So we will branch out for merge sort 0, 1. So what do we see over here? We branched out for merge sort 0 and merge sort 1. Again we hit our base cases because these both are single elements. So what do we do now when we hit both our base cases? What do we do is we start merging them. And what is that merge step? The merge step means that merge both of these unsorted arrays into a single array such that the new array is sorted. So we would be merging these two arrays 18 and 35 or these two subproblems merge sort 0 and merge sort 1. So what would be our new sorted array? It would be 18, 35. So what is the answer to merge sort 0, 1? It's 18, 35. And what would be the answer to merge sort 2? That is 2 itself because it's a base case. Then the answer to merge sort 0, 2 would be that merge the array 18, 35 and 61. So we would be merging them. And what is the merge step? Again, merge both the unsorted arrays to create a new sorted array. So when we merge both of these subproblems, so what do we get? We get a new sorted array of 18, 35, 61 over here. So then what would be the answer to merge sort 3, 4? We would be branching out for merge sort 3 and merge sort 4. But we hit our base cases again because they both are single elements and they both are sorted. So what do? We do merge them. And by merging, what do we mean? To create a new array which is sorted. So, and how do we create that array? By merging these two subproblems. So what would be the new array? The new sorted array would be 48, 73. So what would be the answer to merge sort 0, 4? The answer to merge sort 0, 4 would be a new sorted array that would be created by merging 18, 35, 61 and 48, 73. So how do we merge them? We just merge them by creating a new array and that array would be sorted. So what would be that new sorted array? That would be 18, 35, 48, 61, 73. So the answer to merge sort 04 would be this one, or 18, 35, 48, 61, 73. So the same way we would be sorting the elements present in this subproblem as well, and then we will hit our base cases. So what do we see over here? Does this recursive tree has an optimal substructure? Yes, this recursive tree has an optimal substructure because with the help of all these base cases and all these subproblems, we could sort our intended problem. But can we apply dynamic programming over here? No. In spite of having an optimal substructure, it doesn't guarantee us that this problem can be optimized with the help of dynamic programming. Why? Because what did we do in our Fibonacci series? We just made use of all the extra calls that we were doing. And what was those extra calls? Those extra calls were overlapping subproblems. But do we see any overlapping subproblem over here in this recursive tree? No, we do not see any. Hence, even if we have optimal substructure, but we do not have overlapping subproblems, so we cannot optimize this or these kind of algorithms with the help of dynamic programming. So keep in mind that even if we have optimal substructure, then also we cannot directly apply DP onto it until unless it has some overlapping subproblems as well. So the algorithmic paradigm which merge sort uses is actually divide and conquer, and the worst case running time in this case or for merge sort is n log n, and we wouldn't be able to optimize it further with the help of dynamic programming as told you earlier. So if you still wanna discuss this, and if you still did not understand what all we discussed just now, so please rewind the video and just look at it once, because it's quite an important topic to just make a distinction between such problems and the problems which we really need to optimize with the help of DP. So I wouldn't be looking into the code for this, but I have shared it with you into the repo. You can have a look at that code over there itself. So in the next lecture, we will be starting with our dynamic programming problems, and we will see how to optimize those recursive problems with the help of DP. So meet you in the next lecture. Till then, thank you.